11.2 question 3 deals with the volume of cylinders. Now there's A, B and C. I'll just do A and B. C has nothing special to offer except that A is in centimetres, so my answer will be in centimetres cubed. B is in metres, so my answer will be in metres cubed, and C was in millimetres, so the answer would have been in millimetres cubed. But apart from that, part C has got nothing to offer whatsoever. So this is page 181, 11.2. Now, volume of cylinder. We know that the volume of cylinder equals pi times radius squared times the height, pi r squared h. You may recall that the pi r squared part is in fact the area of a circle. So if you imagine this, I'm trying to dot it in nicely, looking all arty, the radius at the bottom there would still be 6 centimetres, just like at the top, right? So it now looks all lovely and 3D and arty. Well, it's trying to look arty anyway. So the top part here has an area of pi r squared, and if I multiply by the height, I've got myself a three-dimensional object. I work out the volume. Let's just substitute it straight in. Pi is 3.14 approximately, multiplied by 6 squared, because the radius is 6, multiplied by the height, which is 14. So we quote our formula, substitute the correct numbers, and then pick up our calculator. So I'm going to say 3.14 times 6 times 6 times 14. That'll give me an answer. Here it is, 1582.56 and centimetres cubed, because it's a volume. Now part B, this cylinder is lying down, it's laid back like a lot of you people who are watching this video now. So don't be fooled into thinking the 32 metres is the radius. It's not. You're actually looking at one of these little things, okay, like that, lying down. So the 32 is actually the height, and the radius given to you is actually the 8.4 shown then. It actually looks like a radius, and there's the centre of the circle, and there's my centre, and there's me trying to be all 3D and arty. Same again, volume equals pi r squared h equals 3.14 times the radius squared, there it is, the 8.4 squared, multiplied by the height of 32. So I'm getting an answer in metres cubed. Hopefully it will fit there. Right, 3.14 times 8.4 times 8.4 times 32. What we're going to get? That gives us a big number in metres cubed. So I'm going to round it off a little bit. It goes 7089.868. Let's call that 0.9 metres cubed, because it's getting too silly. Okay, 2dp just to match that one. So I have got 868, that's going to be 87 to 2 decimal places. Alright, so volume A, volume B, centimetres cubed, metres cubed, depends on the units. What they haven't got in this book, and they should have had, is an example of a cylinder where they give you the diameter. If you're given the diameter, please don't use pi r squared h. First of all, work out the radius by taking the diameter and dividing by 2. So I better write you a little note. So dangerous. Note. If given the diameter, remember to divide by 2 to get the radius. Otherwise you're going to be so out. Alright, that's question 3, and turning over. Right, question 5. Lovely. For each prism shown below, work out the area of the cross section. In other words, the area of the front face. So if I take this in green, this is the front face. If I work that out, then I can do part 2, which says work out the volume, which is basically multiply my answer by 7. Same with this one. If I just greenify this, so that's my front face there, my cross-sectional area, or area of cross-section. If I work that out, then I can just multiply it by 8 deep, and I've got myself the volume of this compound shape. It's a compound shape because the shape at the front doesn't have a particular name. 1, 2, 3, 4, 5. Call it a pentagon, but it's not regular. so we can't do any mathematics with regular pentagons. I'll get back to that in a minute. Right, cross-sectional area at the front. We'll do that first, shall we? Break it up into 2 bits. So we're going to do this little block and this little block separately. If we do the top block, we've got 8 tall, that's 8, that's 8, and that's 10. That little part must be 2 only, because 2 plus the 8 makes 10. It goes in 7 deep, so that's going to be 7 as well. So my front part here, the top block is going to be 2 by 7 by 1. That's going to be 14 centimetre squared. Oh no, that's just the volume I've done. No. He wants the surface area. Sorry, I'm going straight into volume here. Right, if that is 2 across there, and that is 1 across there, and so it's going to be 1 here as well. And if that's 1 across, then that's 6. I'm not worried about that. Let's just do the front bit. So it's going to be 2 times 1 up the top. 2 times 1 equals 2 centimetres squares, and this part's going to be 6 by 8. So 6 times 8 is 48. 48 centimetre squares, and altogether total cross-sectional area. Total or area of cross-section that's going to give us 50 centimetres squares. So now the volume of this shape makes sense to do it together. It's going to be the area of the greeny, which is 50, multiplied by 7 deep. Well, 5 7s are 35. 350 centimetre cubed of volume. Easy. Sorry about the mix-up earlier. I went straight into volume. The whole point is they really do want the volume of a prism. This is about volume of prism only. So this is really a lead-in to working out what they really want, which is the volume. And that really helps for this next part here. Now look, I've got a rectangle. I know it's not brilliant, but that's actually a rectangle. And this part, who knows what that is, but anyway, we could do that in a minute. I think that's a triangular face, that part. So I've got a triangular prism for the top and a rectangular cuboid at the bottom. Had I drawn it perfectly, it would look more like, you know, that would have been true. Anyway, let's do the area of this. Well, if that's 17.5, so is this 17.5. And look, this has been carefully drawn for us. The height of this triangle is in fact 3 centimetres. There's the right angle there. So it's going to be half base times height. So top part's going to be half times the base, 17.5, times the height of 3. Get an answer for that. So 17.5 times 3, then divide by 2. That gives me 26.25. Again, we're doing an area, so it's centimetres square. Now the bottom is just going to be 4 times 17.5. Alright, it's just the base times the height for a rectangle. Pick up my hardware and do that now. 17.5 times 4, and that's 70 centimetres squares. So total area of cross section is going to be 70 plus 26.25, giving us our 96.25 centimetres squares. That's not the whole story. We want the volume, don't we? So the volume is going to be all this lovely greeniness here, which is 96.25. We're going to multiply that by 8 deep. We've got no mixed units at all, so we can just happily multiply 96.25 by 8, and that will give us an answer 770, and that will be centimetres cubed. Okay, there's no mixed units anywhere, so I'm really happy with that one. That's that. Notice it says A and C, but I didn't bother doing B because it's no different to A really. So we've got two cuboids stuck together to make this lovely little block. I've got a cuboid and a triangular prism on top to make this little shed thing arrangement. Next question, question 6. It says a cylinder of height 3.2 meters has a volume of 15.68 meters cubed. Better just draw it, it's going to help, isn't it? So I've got one of these. Now, join it. Let's make it look 3D. Again, looking inside a little glass cylinder. Right, the height is, so from there to there, I've got 3.2 meters. And the volume, let's put it inside there, is going to be 15.68 meters cubed. Work out the area of the base of the cylinder. In other words, they want this. Now, do you remember I told you that the area of the circle is pi r squared? But since they don't want us to work out the radius, we don't even need to use that. We know volume equals pi r squared h. And this part, let me just highlight it, this part, the pi r squared bit, is the area of the circular base. So how do I find this little part? I just take my volume and divide it by the height. So my area of the base is going to be my volume divided by my height. Okay, just take this over and divide it. It's a standard equation. Let's make the h look like an h and not like a b. Take my two numbers. Volume, what is it? 15.68 meters cubed. Please note it's meters cubed the unit. You don't go cubing the 15.68. Divided by the height, which is 3.2 meters. Pick up the hardware. 15.68. Divide that by 3.2. That gives me 4.9, and we're in meters squared because it's an area. Okay, area meters squared, and that's question 6 done. I love question 7. I think it's on the other page, and with this I will stop section 11.2. It's a beautiful question if he lets me do it right. It's one of these thinking ones. It's lovely. It says the diagram shows a plastic pipe of internal radius 4 centimeters and length 60 centimeters. So don't know how well it appears on your video there, but the radius of this cylinder on the inside from there to there is 4 centimeters. Alright, and the plastic has a thickness of 1 centimeter. There is the extra 1 centimeter there. So effectively the radius for the outer part is going to be from the edge there through the plastic right to the middle again, and that's going to be 5 centimeters. Alright, so we have, if you like, empty space that we can blow through the middle of it and blow out all the cobwebs, and the radius is 4, but the entire tube will have a radius of 4 plus that extra little 1 thickness, which gives us a radius of 5. Alright, now calculate the volume of the plastic in the pipe, the actual plastic. Now what have we got? We have a tube with a radius of 5, we can work out its volume, and we have an inner tube which is completely empty with a radius of 4. We can work out his volume. Essentially we work out the two volumes and subtract them. By subtracting them we're saying there's nothing actually in the middle, therefore we take it away, we're just left with the volume of the plastic of which the pipe is made. So here I go. Let's work out the volume of the empty space. So V equals pi r squared times h, which equals 3.14 times a radius of 4 squared times a height of 60. Put that into the machine. So 3.14 times 4 times 4 times 60, height of 60, that gives me 3014.4 centimeter cubes worth of empty space. Now let's work out the volume of the whole thing with a radius of 5. It's meant to be like an arrow. So quote it again, V equals pi r squared h. It's the different radius this time. 3.14 times 5 squared times the height of 60. Now we get an answer. 3.14 times 5 times 5. Oops, error. 3.14 times 5 times 5. I could have just called it 25, couldn't I? Times 60. And that gives us 4,710 centimeters cubed of, well, solid plastic through and through if it was, but it's not. Now I'm going to subtract them. So volume of plastic is going to be the volume of the whole thing as if it was solid. Take away the empty space, and that will give me the chunky plastic around here of thickness 1 centimetre. So I've got 4710 take away 3014.4. That gives me a volume of 1695.6, and it's in centimetres cubed, and that's what I make it, and I'm sticking to it. So I'll stop there. That's 11.2 done, volume of a prism, and I'm going to start preparing for 11.3 quite soon.